छुड़ाएगा मेरे को दे देना शॉर्ट कर।
Describe experiment to demonstrate phenomenon of to determine wavelength of monochromatic light. I'm just drawing one diagram of this experimental deduction. It consists of horizontal metallic bar, usually 2 meter long, fitted with meter scale. It consists of horizontal metallic bar, usually 2 meter long, fitted with meter scale. It carries 4 stands. It carries 4 stands. Just draw this much first. This lines you draw very light line because they have taken this for reference something. Completed this much, then I'm just drawing further. It consists of horizontal metallic bar, usually 2 meter long, fitted with meter scale. It carries 4 stands. These vertical lines which I am drawing, they are stands. It carries 4 stands. Four stands. Draw properly diagram. R1, R2, R3, R4. It carries 4 stands R1, R2, R3, R4. Stand R1 carries slit. Stand R1 carries slit. Slit means opening through which light can be incident. R1 carries slit. R2 carries biprism. R3 carries convex lens. This is called micrometer eyepiece. Two cross wires are mounted on the screen fitted on eyepiece. From here we are observing. Diagram is done with you all? Yes, completed the diagram?
Yes, sir.
Okay. Write down. It consists of. It means this Fresnel's biprism experiment. It consists of horizontal metallic bar, usually 2 meter long, fitted with meter scale. It consists of horizontal metallic bar, usually 2 meter long, fitted with meter scale. It carries 4 stands R1, R2, R3, R4, which can slide on horizontal metallic bar, which can slide on horizontal metallic bar. The stand R1 carries slit. R2 carries biprism. R3 carries convex lens of very short focal length. R4 carries micrometer eyepiece. Two cross wires are mounted on the screen fitted in eyepiece. It can be moved transversely. Transversely means perpendicular to the path of light. The entire arrangement is called as optical bench. Entire arrangement is called as optical bench. If completed, tell. Completed?
Yes, sir.
Okay. Now we did explanation of apparatus. Now adjustment. And then final will be calculations. Adjustments. The slit, comma biprism, comma eyepiece are aligned parallel to each other, because that stands we can rotate, so we make them parallel to each other. The distance between slit, comma biprism is kept at 10 to 15 centimeter. The eyepiece is kept at nearly 100 centimeter away from slit. Now the slit is illuminated by monochromatic light of wavelength lambda, which is to be determined. The interference pattern is observed on the screen in eyepiece. interference pattern is observed on the screen in eyepiece. Can I clear now again?
Yes, sir.
Okay. Others have also done? Huh? Okay.
Yes, sir.
Yes, sir.
I'm not done. Last line पे थी मैं.
अरे क्या बोलते हो, जोर का बोलो, थोड़ा कुछ खाओ खाने.
I'm on the last line. Just a second.
Okay.
Done, sir.
We did apparatus, that means construction, adjustment, now measurements. Actually, we have to determine lambda. Fringe width. From last lecture, I know it is lambda d by t. Now, if I want to find lambda, I should find fringe width capital D small d. Fringe width capital D small d. Out of these three, which can be found easily? This means distance between consecutive bright or dark. This means source and screen. This is two coherent virtual source. Two coherent virtual source मतलब एक से दो light निकला. We assume it is coming out from S1 S2. Which one we can find fastest or easiest?
Capital D.
Capital D, because it is direct distance between this R1, that is slit, and eyepiece on R4. This I can see from that meter scale fitted directly. So wherever it is coinciding, wherever this is coinciding, subtract. Suppose this is coinciding at 5, this is at 105. So 105 minus 5, 100 centimeter is our distance T. First part clear? Distance capital D between slit and eyepiece can be found directly with the help of scale fitted on horizontal metallic bar. Horizontal metallic bar. Please write this much. Fitted on horizontal metallic bar. Completed?
Yes, sir.
Okay. Second. Now see, this is screen on which we have two cross wires, and here we are having bright, dark, bright, dark, bright, dark, bright, dark, bright, dark on the screen. So what we do, this cross wire is made to coincide with any one of the bright band, and distance x0 is noted. Now if next bright is x1, then x1 minus x0 will give me fringe width, which is distance between consecutive bright. But because two brights are very close, so we don't only read first and second. We make it to move this cross wire on many bands. Suppose it is here, then x2 minus x0, when I divide by 2, I will get fringe width because there are two bands. If I go on third, then x3 minus x0 divided by 3. If I go on nth, then it is xn minus x0 divided by n. So to determine fringe width, this cross wire first is made to coincide with any one of the bright band and x0 distance is noted. Then it is made to pass over nth bright band and distance xn is noted. Then xn minus x0 upon n is called fringe width. So first line I am writing like this: the cross wires are made to coincide with any one of the bright band and distance x0 is noted. Then the cross wires are made to coincide with nth bright band and distance xn is noted. Therefore, fringe width denoted by capital X equals to xn minus x0 upon n. Right. Completed? Yes, completed. Hello? Completed?
Done, sir.
Done, sir.
Okay. Everybody has done that because
Yes,
next
sir.
one, next third one. In this entire experiment, mostly this is what they will ask you in there. To determine, mostly they ask with ray diagram, explain method to determine distance small d between coherent virtual sources. Heading right, then I'm explaining few concepts, then starting with the diagram. Mostly they will ask you this for 2 to 3 months. Two terms of 11th standard, just see what it is. Even in 9th, 10th you have done. Linear magnification. It is defined as ratio of height of image to the height of object or distance of image to the distance of object. And power of lens is defined as reciprocal of focal length measured in meter. SI unit is diopter. Then one you have done angular magnification. This is ratio of, or it is also called magnifying power. Ratio of angle subtended by the image at center of lens to the object when placed at distance of distinct vision and seen directly without lens. This two part we don't want now. 11th का है, मुझे ये चाहिए जो 10th का है. Ratio of height of image to the height of object is called linear magnification, or ratio of distance of image to the distance of object is called linear magnification. To determine distance small d between coherent virtual sources. Because it is virtual, we cannot see it, hence we have to find its image which is found on the screen. Object is virtual. Between coherent virtual sources, a convex lens of short focal length is interposed. Interposed means in between. Is interposed between source and screen and adjusted in two conjugate positions L1, L2. Conjugate position means if object is at 30 and image is at 70, at one case, next में उल्टा करना है. Object is at 70, image is 30. इसको बोलते हैं conjugate. Now short focal length we take so that the rays will converge within the focal plane. नहीं तो बहुत दूर होएगा, it will be difficult to adjust that eyepiece on which there is screen. इससे short focal length. Focal length पे converge होता है. Converge हुआ है तो bright dark मिलेगा. So first paragraph write down, then I'm explaining how we are going to calculate. to determine distance small d between coherent virtual sources. A convex lens of short focal length is interposed between source and screen and adjusted in two conjugate positions called as L1, L2. Means we have interchanged object with image, image with object. Can I clear to draw ray diagram?
Done, sir.
Okay. Now, along with me, you will draw ray diagram to get image. So first, with pencil, if you are having at home, draw one very light line. This is position of object. Very light line you draw. Then take 3 centimeter, draw another line. This is for lens. Then take around 7 centimeter, draw another line. This is for conjugate position. Then again 3 centimeter, draw a line. Which for symmetry we did, so that object and image distances will not get disturbed. And 2 horizontal lines for again symmetry. All are light lines. The skeleton please draw. Then if you are having ruled line, one line above, one line below, take S1, S2, this D we have to calculate. Exactly same here, one above, other below. Here there is lens, position is L1. And this is L2. From S1, draw a line passing through optical center. Draw line passing through optical center. Same way for this, draw line passing through optical center. This is S1 dash, S2 dash, height is D2. D1. Height is D2. This is object U1, image D1, object U2, image D2. Completed?
Done, sir.
Just write down below this. At conjugate position L1, lens is close to the screen, close to the source, and magnified image S1 dash comma S2 dash of height D1 is obtained. Let U1 comma V1 be the distances of object and image from lens respectively. Object and image from lens respectively. From lens respectively. respectively. Right. Therefore, d1 upon d equals to v1 upon u1. This is actually linear magnification one formula. Then add conjugate position L2, lens is close to the screen, and diminished image of height, diminished image S1 double dash S2 double dash of height D2 is obtained. Let U2 comma V2 be the distances of object and image from lens respectively. Object and image from lens respectively. Therefore, D2 upon D equals to V2 upon U2. But V2 equals to U1, U2 equals to V1. Therefore, D2 upon D equals to U1 upon V1 equation. Multiplying equation 1 and 2, we get D1 upon D into D2 upon D is V1 U1 upon U1 V1. V1, V1, U1, U1 cancel. So therefore D1, D2 upon D square equals to 1. So D square equals to D1, D2, D equals to root D1.
Done, sir.
Okay. Everybody has done?
Yes.
Now one last line.
Yes.
Fourth point, yes, fourth point. Since fringe width is lambda d by d, so lambda will become capital X d by d. Using above formula, wavelength can be determined. Wavelength can be determined. Done na full?
Yeah, sir.
Actually, interference we have completed. Chapter is interference and diffraction. Interference part we have completed. Time is not there. One ray diagram I have to draw for interference that completes full interference and diffraction. एक मिनट नहीं भाई नहीं करता मेरे को समझेगा नहीं